Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Now, this first one is kind of unfair because it's a very simple non-related rate looking problem, because most related rate problems are nasty looking word problems. But in this one, it's just an initial setup of how do the mechanics work. So they give me an equation. They say if the rate of change of x with respect to time is 5, so dx dt is 5, and the rate of change of y with respect to time, we don't know. So we want to find that when x is equal to 2. So we're given dx dt. So I've read it. I mean, this kind of, there's not much I could say about this. I've read it. Yay. I understand what's going on here because there's no picture I can draw. So I'll just say, yeah. Next thing we're going to do is list out the knowns and unknowns. So we were given the following. We're given that dx dt is equal to 5. We're actually gifted an equation. That is usually never given. So we are also given that y is equal to x cubed plus 2x. Sorry if my voice sounds hoarse. I've been talking for what seems like a year. And then the unknowns, or what we want. How's that? I'll call it want because it's just easier to write that. We want dy dt, the derivative of y with respect to time. And this is when x is equal to 2. Notice my notation. I want to find the derivative of y with respect to t when x is equal to 2. So this is telling me actually that I'm going to be taking the derivative of this function right here, not with respect to x, but with respect to t. And that's actually going to be the case for the vast majority of related rates examples. You have a couple variables you're working with and they both change with respect to time. And that creates a relationship between them. And so we can consider y to be a function of time and x to be a function of time. That's how you can kind of consider these problems. This is like a parametric equation that you have from pre-calculus. So I've read, I understand, I've labeled. That's probably a good way of saying that. Let's see, I hop back over here. I'm just looking at the list. Write a master equation. Well, they gave me a master equation, so I'm going to say check, step 4 is done. And now we create a rate equation. So I put a little check mark there, master equation, me, right? And now I want the rate equation. Now the rate equation just means take this master equation right here, this is the master equation that you're seeing right there, and take the derivative of both sides implicitly with respect to t. I'll show you what that means. So rate equation. Take the derivative of the left-hand side with respect to t, and take the derivative of the right-hand side, again, with respect to t. So we'll just do this. And this implies that we have dy dt equal to, now this is with respect to t, so this is not just going to be a 3x squared. It's a 3x squared, but then times the derivative of x with respect to t, plus 2 times the derivative of that x with respect to t. That is our rate equation. And this is why implicit differentiation was so important to learn in our previous section. It's going to haunt us for quite some time, so we want to make sure that we're really good with that. If you need to review that, please review my related, or not my related, but my implicit differentiation video several videos ago. Now at this step, I just kind of call this step the sub-in step. So I'll just hit sub-in here. And let's see, what are we substituting in? We're given that dx dt is always 5, that x, the rate of change of x with respect to time, is constant. It's constantly 5. So I can sub in 5 for dx dt. So I'm just going to say let dx dt equal 5. But also, because we want dy dt, notice where I'm looking, by the way, the givens and the wants. What we want is to find dy dt when x is equal to 2. So we're going to also sub in x equals 2. So, and x equal 2. So let's see what happens. When you do this, by the way, you're assuming that x is 2. So we're actually looking at dy dt right now when x is equal to 2. It's going to be 3 times 2 squared. If you're wondering where I'm looking right here. Dx dt is 5, always, that's what they told us, plus 2 times 5. And that is an arithmetic problem, right? So what is that? 4, 12, 60 plus 10, 70? Forgive me if my arithmetic is wrong. That's good, actually. So, all right, dy dt when x is equal to is 70. We don't even know what the heck that means. It just means that the rate of change of y with respect to time at x equals 2 is going to be 70. Now, because this is not a physical problem, in other words, it doesn't represent anything physical, no physics are involved here, this probably doesn't make very much sense to any of us, and that's fine. By the way, that last few steps there, I sub in, actually is what I would probably call the next step. So I wrote that as 5.5 there, sub in, and then solve and check and state the solution. And that solve and check and then state the solution is usually kind of a reality check. Does your answer make sense in a physical situation? And while that would work for most related rates problems, the one we were just working on it will not work out. That is, there's no way to understand whether that makes sense or not. It just is.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.